Now this is where the significance of increasing the hidden layer comes into picture. 4 neurons, so I can add another 4, and then I have another hidden layer. So this depth is 2 neurons. So we got 2 hidden layers, and the first layer has 8 neurons, the second layer has 2 neurons. All right, perfect. Now we're gonna keep all these activation functions and everything else the same. Let's go and try this now. If you see, the training loss is reducing proportionally to the test loss, and as you can see, the network is trying to achieve some significant improvement, but you see that at some point it's kind of stuck. So this is what happens if you use ReLU. Now what we're going to do is we're going to increase
and
the
also
neurons in the
change
second
the
layer.
activation function to sigmoid.
So I'm going to make it 4, and let's run it. Now if you see, it's going below 0.480, which is a good thing, and we are roughly about 100 epochs here, and you see that it still doesn't improve the output significantly. Let's pause it. Now let's increase another hidden layer here. So now we have 3 hidden layers, one with 8, one with 4, and one with 2. Now let's see how this performs. And if you see, the output is still not the best. So now what we're going to do is we're going to increase the number of neurons. So we're going to keep 8 here, we're going to make 6 here, and we're going to make 4 here. So let's go and change the activation function to 10h, and let's see how it performs. Right off the back we have 0.475 right here, but here, and 0.46, and there you go, it's actually doing the magic here, and you see that it's actually trying to find its solution. So what we understand is that the activation function played a very critical role. However, you had so many different layers, the activation function plays a critical role in finding a solution. So just by having more hidden layers, it does not mean that you might solve the problem. But you see the weights are becoming really heavy here. This one is especially very heavy, it's 4.4, and you can see what the output of each neuron is. As you can see, here it is more linear, and here it is more fuzzy and non-linear. And you can see here it has more characteristics in the output. Right, so here we are at the training loss of 0.026, which is not a bad thing, which is not bad at all, which is 99.98, which is a good thing, and it continues to increase. So I'm going to pause it right about here, and it's 778. So you can try all of this with regression as well, changing the activating function, learning rate, the data, and so on. Hope this was a lot of fun. We saw the significance of hidden layers, we saw the significance of the learning rate, we saw significance of the activation functions, the regularization parameter, and also we solved for classification.